Okay, so that was rational functions. Now the nice thing about rational functions is their end behavior is going to be the same on either side because it has that horizontal asymptote. But when you have rational radical functions like this one, they frequently have a different asymptote depending on if you're positive or negative. So let's look at this example. So we have the limit as x goes to positive infinity. Once again, I'm going to ignore my small terms and only look at my big terms. So limit as x goes to positive infinity of square root of 4x squared over x. If I simplify that, I'm going to get 2x over x, or 2. Now, however, that was for positive infinity. Now let's look at negative infinity, because as we all know, if I am looking at the square root of 4x squared, the answer to that is not just positive 2x, because roots, sorry, that should be negative infinity, have a plus or minus. So we also have a negative 2x. So that is a negative 2. So whenever you have this root, remember we have the plus or minus, which means your positive infinity and your negative infinity are going to have different answers. Okay, last few. Use the end behavior of y equals e to the x to find these limits. So first one, if I think about my e to the x graph, it's going to look like that. So as x goes to negative infinity, I'm going to get closer and closer to 0, negative infinity that way. As I go to positive infinity, I'm going to get closer and closer to infinity, or you can just write does not exist. Anytime you have infinities, you can technically write does not exist, because the limit of infinity isn't an actual number. Now, for this one, I need to start to simplify some things. So this one, get rid of my small terms. So I have my limit as x goes to infinity of, I'm going to change e to the x as 1 over e to the x, make that negative exponent into a positive, plus 2x squared over x squared. Now if I think about these limits as I'm going to infinity, so e to the x grows really, really fast. 1 over e to the x would get closer and closer to 0 because it's 1 over a really, really big number. This one, our x squareds go away, would just be 2. So we get 2. Now let's look at this one. Now here's something to know. When they're all combined in 1, exponentials will always grow faster than any polynomials. So this exponential is going to outpace everything else. The exponential always wins. So what this really becomes is the limit as x goes to infinity of 1 over e to the x. That's the same one where the bottom is growing really, really, really fast. So that's getting closer and closer to 0. There's your limits at infinity. Don't forget to do your homework.